Okay.
Okay.
Okay. Assalamualaikum. And today we will present about our assignment, digital signal processing, that were given by Madam Isadora binti Mustafa about classification linear time invariant system. Okay. I Muhammad Nur Aizat bin Rahmat, and with my two other partners, it is
Muhammad Syazwan Hafiz bin Roslan.
Muhammad Nur Iman bin Sulaiman.
okay. So we will present two classification linear time invariant that we choose from 5 classification. Next slide, show the 5 classification. Okay, the 5 classification is linearity, time invariant, stability, memory, and causality. In this classification, we choose time invariant and stability. Okay, first and foremost, for the time invariant is a time invariant or TIV system as a time dependent system function that is not a direct function of time. The time dependent system function is a function of the time dependent input function. If this function depends only indirectly on the time domain, then that is a system that would be considered time invariant. So conversely, any direct dependence on the time domain of the system function could be considered as a time varying system. For the next slide, for the example, this are for the simple example to demonstrate how to determine if a system is time invariant. Consider the two systems. System A, yt equal to txt. System B, yt equal to 10xt. Since the system function yt for system A explicitly depends on t outside of xt, it is not time invariant because the time dependence is not explicitly a function of the input function. In contrast, system B is time dependent, is only function of the time varying input xt. This makes system B more time invariant. Okay, for this example from the past slide. Okay, for system A, we will start with a delay of the input. It is xdt equal to xt plus d. That symbol is the delay. So the example given was yt equal to txt. So txt we must substitute with the delay of the input. So we use another variable. It is y1t equal to txdt equal to txt plus d. So at here we will see the xt will substitute with the delay of the input. So it will become tx bracket t plus d. Okay, now the delay, the output by delay. Okay, yt equal to txt. Okay, so we change the variable to y to t. So why the t is not become t? So why become y? Because it is output delay. So the y will permanent and not change. It will change until we put the delay of the input. It is t plus d, so equal to t plus d x time t plus d. Clearly, y1t is not same y2t. Therefore, the system is not time invariant. Okay, for system B, we start with a delay of the input xdt, same for the system A. Same substitution. So for yt equal to 10xt. So we change to another variable, become y1t equal to 10x dt. So at xt, we substitute the delay of the input into the y1t. So it will become 10x t plus d. So at here, the 10x, the variable of x not change because it is input. Because we do in input, if we do in output, the variable will be y. So now delay the output by d. yt equal to 10xt. So change variable to y to t equal to y. So y, we change 10x to y because the output. So y substitute with the delay of the input will become t plus d equal to 10x t plus d. So clearly it show y1t same y to t. Therefore, the system is time invariant. Okay, next slide.
Okay, for the real world example, we start from stability, which is bounded input, bounded output, and we call BIBO. Stability is a form of stability for linear signals and systems that take inputs. If a system is BIBO stable, then the output will be bounded for every input to the system that is bounded. So below is the example of Bimbo for discrete time signal or continuous time signal. Next.
Okay. Okay, next I will explain about stability. Stability is about bounded input to bounded output yn, where Sn and Yn does not have value of infinite at all values of n. Stability is important for practically because no computer or any digital processor can compute using infinite value. When computation cannot be done, the system will hang or crash. So it is important to keep the system stable by avoiding the infinite value. Okay, this is an example for stability, which is Yn equal to uh, sum of Sk. In the example, boundary input does not ensure boundary output. If Sn equal to Un, a unit step, and when n is equal to infinite value, y infinite we will have infinite value where y infinite equal to 1 plus 1 plus 1 and so on until infinite value. The system is not stable. If Sn equal to uh, sigma n and impulse signal Yn will always be equal to 1 for any value of n, thus the system will be stable.
Okay, for the real world example for time variant, as the description by Isaac, the time variant is about a delay time. So a time variant TIV system has a time dependent system function that is not direct function of time. Time variant, for example, such as direct application is circuits. So on the right, we can see the simple circuit. So an electrical network is an interconnection of electrical components of a model of such as interconnection consisting of electrical elements. An element circuit is a network consisting of closed loop giving a return path for the current. Linear electrical networks, a special type consisting only of sources, linear lump elements, and linear distributed elements, have the property that signals are linearly superimposable. They are thus more easily analyzed using powerful frequency domain methods such as Laplace transform to determine DC response, AC response, and transient response.
So that's all for our
That's all.
explanation.
Thank you.
Thank
Thank
you.
you.